All right. Today we're going to talk a little bit about surveying, some of the components, the tools that we use, and then kind of at the end of this presentation, we're going to talk about how we read the rods, which is going to be really important when we get into lab, understanding how we read the rods in surveying equipment. So when we talk about surveying, we got to kind of understand like what is surveying, okay? And surveying is basically measuring distances, angles, positions on or near the surface of the earth. In some cases, we're going to count for the curvature of the earth. In most of the cases, kind of what we're going to be dealing with, we're really not going to be focusing on the curvature of the earth. We're going to assume, even though it's not a flat earth, we're going to assume that the earth is flat because of the large scale of what we're dealing with and the small distances that we're going to be measuring. We don't actually need to take that into account. Where we use these things, and you probably see these things all the time when they're building, roads, bridges, pipelines, canals, when you have to worry about flow of water, understanding where high elevations are at versus lower elevations. All of those things are going to be out. We also do this to measure, our states, break our states up, break our nation up, break our counties up, our cities up. If you buy a house, you buy some land, you're going to have some surveying that's going to be done on that as far as what we talk about for like legal land descriptions. We're really not going to get into that, but that is kind of what we do with surveying. Surveying is an art because to read the rods and to kind of measure these things out, not all of it is going to be precise. Some of it is a little bit of like the feel and the touch of the equipment. But it's also scientific because you're actually like measuring, collecting data, using that data to tell you different things, to actually apply surveying into kind of the world. So we're dealing with both kind of the art of handling the equipment, utilizing it, and then actually collecting data and determining certain things. When we get in the lab, we're going to talk a little bit more about the scientific side of things, but we'll also kind of demonstrate the art of it as well. There are really two basic types of surveying. There's plane surveying, which the shape of the earth is spherical. That means the surface of that is curved, albeit very, very slight. In plane surveying, the curvature of the earth is not taken into account. So like we've said, this is something that we are going to be dealing with. And most of the stuff with like agriculture, there are very few operations where we actually are going to bring the curvature of the earth into account because we're not dealing with things over a very long space. Most of the time, if you could see like behind my head here, about 100 square miles, we're going to be considering plane surveying. Some of the times we might be in a lot of agriculture. We might be doing a quarter of a mile run for a field, and that might be maybe half a mile, but we probably don't typically go much more over than that. So really 100 square miles, we're really going to kind of fit within that type. Geodetic surveying is things that are going to be over 100 square miles. So you're joining those points together, talking about curved lines. If you talk about the longitude and latitude lines that we deal with, the 59th parallel or different things that we have as we break up the world, that's more of like geodetic surveying. When we talk about things like contour maps and lines that you see, if you ever go up in the mountains and you see little lines indicating different heights, those things are all going to be a geodetic because they're doing over a large area, telling telling all the different numbers, the different heights, lots of different information that we can kind of go through with that. So these things are a little bit more fine-tuned measurements because we're doing it over a large area. We need to kind of have a little bit greater accuracy as far as that stuff goes. Some different ways that we measure. We used to measure in a chain, which they used to literally have a chain. There was 100 links. Those chains, all the links together, ended up being 66 feet long. That's not necessarily something that we use all the time, especially in kind of the stuff that we're doing in agriculture. That's really kind of gone away. We use feet, we use miles. Those are kind of the basic things that we're going to be kind of dealing with. In a mile, there's 5,280 feet. So if you go a mile, that's how many feet you are going. If you don't know this number, you should know. There are 43,560 square feet in 1 acre. That ends up being 10 square chains. kind of where the chains kind of comes in, and we still use it today, although we don't really demonstrate it with the chain. But that weird number, that 43,560 square feet, that's how many square feet are in an acre. And we use that all the time in agriculture. The 10 square chains is a more balanced number. That's where we're getting that. We're using kind of the older style measurements and still utilize that today just because that's what we've done. 1 square mile is what we would call a section of land, and that is 640 acres. And we do still use that when we talk about the legal land descriptions in, buying parcels of land. Do you have a whole section? Do you have a portion of that section? That's where that stuff kind of comes in. The other thing we do is a pace, and basically a pace is when we walk a certain amount, and then we calculate that based off of like a known dimension. So we might walk 100 feet, and we count how many steps we make, and then we'll go walk an unknown distance, and then we'll say, oh, this takes this many steps. Okay, your pace is basically how many feet you step for every step, and you can get a guesstimate of how long that distance is. We're going to be doing that in lab, so that way we can kind of check that out. So I'll demonstrate that when we get into lab, how we actually do our pace. I guess we're going to talk about it right now. So it's an approximate result. It's an approximate answer of where things are at. For instance, if I walked 100 feet and it took me 25 steps, I might walk 50 feet, and I could assume that if 25 is 100 feet, that 50 steps would be 200 feet. The math's not that hard. We'll figure out we'll do some measurements to figure out what our pace is, and then we'll kind of calculate that, and then we apply that to an unknown length that we don't have measured, and it's a great way of just getting a general result of how far we're going. If you're ever up hiking, moving around, if you know your pace, you can kind of get a distance of how far you're going or how fast you're traveling, if you'd even put a time to that as well. Everybody's pace is going to be different. I know for me, I'm about 2.5 feet for every step because I've done it quite a bit, but the length of your legs, all that kind of stuff comes into effect. The slope of the ground. Are you climbing up a hill? Are you climbing down? That can change that stuff. If you're running, your pace is probably going to be a little bit different. You might have a longer stride. So typically what we do when we pace, we walk really slow and we don't run. We be very methodical about our steps and counting them. So that way we can get a better average and a better guess as far as that stuff goes. Some equipment that we're going to be using, we will be using a builder's level, which is basically like a little scope, kind of like what you would see on the top of a gun. And it's got some crosshairs. We're going to talk about how we actually measure that or read that rod. That's going to sight in on that leveling rod that you see there. So it's going to be able to tell us different heights of stuff. Steel tapes are things that we use, especially over like fiberglass and other stuff, because there is a little bit more accuracy to a steel tape. Fiberglass tapes can often, especially over a longer distance, have a little bit more inaccuracies. We also have odometer wheels, which are little wheels that go around the ground. You roll it, and it'll actually just tell you a distance. So it's pretty accurate, unless you have rough ground where it's like bouncing, then you may not be able to get a good reading. And the other thing is the GPS, or Global Positioning System receivers, things like that. You guys all have those on your phone. The accuracy of that stuff may depend on what type of GPS you have in your system, how many satellites those things are pulling from. Sometimes if you ever look at your phone and you're like, hey, where am I at? And there's this big circle, especially if you got an iPhone, you might have a circle that's like a mile wide. Your phone's like, I don't know exactly where you're at. You're somewhere within this mile or this half a mile. If we want to try to get accurate measurements, we need more accurate GPS systems. And some things like Garmin's, those things are going to do a little bit better than what most phones are going to be able to do. Here's an example of some of those. If you look up in the top right corner, that is the builder's level. The leveling rod, this is what we're actually going to be reading, so we use these two kind of in conjunction. The steel tape is typically going to have a holder like this, and it is going to be steel. It's going to have markings on it, but again, it's going to be more accurate. Odometer wheel, you probably have seen these things. Lots of people have. You maybe didn't know what it was, but this thing has a little counter on it. It just rolls and it counts, and it tells you how many feet. They know the circumference of that, and they go around. And obviously a little handheld GPS unit that we can use for stuff. When we are taking measurements between 2 points, that are horizontal. Slope and vertical are recorded in feet. Okay. Horizontal and slope distances are measured by using fiberglass steel tapes, electronic distance measuring. You ever seen like little lasers? You can actually like run those things through, and it'll bounce that laser back, and it'll tell you how far it is. They're actually kind of pretty accurate, and we use those a lot in measuring, like for like carpet. I had a guy come and measure my carpet, and he literally took two little beeps with his little laser device and says, "Okay, I know how much carpet we need to order," and that was it. So he came by for like 2 seconds of work, and they put our carpet in, and it was accurate. So plus they're going to cut it down. They're going to always give you a little bit more. Vertical tape, we can use a leveling rod to measure vertical distances, and that's really where the builder's level and the leveling rod really come in to play, where we can actually take and sight in. So we're going to work with how we actually do that. Again, when we get in the lab, I'll show you how the equipment's set up, how we adjust it, and then today we're going to talk about how we actually read that rod. There's two terms that we really kind of deal with when we're dealing with surveying, and there's accuracy and precision. And for the most part, we might think of those things as just kind of one thing, or really the same word. That's saying, the same thing, just in a different way, but it's not. There actually is a little bit difference between those two. When we talk about accuracy, okay, versus precision, right? Accuracy is how, close, if we look at like the target that we have here, right? It is how close are those dots together on that target. And if our goal is to hit the center of this target, okay, the grouping of those dots, okay, towards the center needs to be better. Okay, precision is the degree, basically how far apart those things are from each other. So if we look at these things, if we're, trying to hit this target here, we've got stuff that's all over the place. It's low accuracy, low precision. When we talk about this one, you can see that we have a very, very tight grouping of, all of our shots right here. That's a low accuracy because we're not hitting the center of this thing. But it's high precision because they're all within the same area. So we're doing the same thing, and we're able to repeat that, but we don't have an accurate thing. So like maybe we're measuring something, and every time we measure it, we get the same reading, but we're not actually reading what it actually is. So we have a high precision, we just have a low accuracy of where it's actually at. On this one, we have a high accuracy and low precision. You can see that a lot of them are pretty close to the center, but they're not a really tight circle, right? And when we get to this final one, we really kind of see that high accuracy, high precision. So we've got small grouping, and we want accurate stuff. So when we're reading and dealing with surveying, this is really what we're looking for, is both accuracy and precision in stuff. So an example of this, when we're dealing with measurement, we might be using a cloth tape, and the true distance, the actual distance of that tape, is going to be 157.22, could be feet, whatever, doesn't really matter. But when we actually measure that stuff, maybe the cloth tape is not accurate, and so we measure 157.3. It's an error of 0.01. For some things, that may be okay. When we talk about our projects, we talk about a 1/16 of an inch off on projects is okay, an 1/8 of an inch if we're doing woodworking. Okay, how accurate do we need to be is really kind of dependent. With a steel tape, we might be able to get a reading of 157.23. So we might have a limit on the amount of air that we have. Over some time, that air will kind of build up. If we're measuring, a distance of 10,000 feet, that air is going to add up, and all of a sudden we might start being a foot off. We might start being 2 feet, 3 feet, 4 feet, 20 feet. That's going to add up, where this one's going to take a lot longer because of the accuracy. More precise methods are going to help become more accurate with those things. Okay, but we might be less accurate with our measurement. Okay, temperature can come into play on these things when we talk about steel tape, especially. The temperature, metal is going to expand and contract, so the steel tape can kind of sometimes be off a little bit as well. There are faults within these things that we have potential problems with. No measurement is going to be free of error. It doesn't matter how accurate we want to try to be. If we take something, right, and we talk about this in the beginning of this class, when we talk about measuring and how we don't really want to use like a permanent marker to mark with, because the thickness of that permanent marker is going to change. And if it's an 1/8 of an inch mark that we're marking, well, where on that mark are we talking about? If we break that down and we put a scribe into something and we scribe a really thin line, that line still has thickness to it, right? It's lower than what a permanent marker is, but it still has thickness to it. And so we need to understand that there's going to be some error within these things. It's how do we minimize that error? How much do we minimize those things? And that's really kind of what we're looking for, okay? What we don't want to have is random error, right? So like, let's say you don't have the skill of reading the rod, that could be a problem, right? Things that maybe tend to cancel each other out. We might make an error. We might have a temperature error. You might have, somebody, surveying error. Sometimes it may be a big deal unless we really need to have that high precision. So if we're trying to like level off a piece of land and we need to have it sloped in such a way so that water kind of comes off, that's going to matter. We're going to need to have, that accuracy with them. Some cases we may not. Some things that may happen are mistakes that we do as we're starting to record stuff down. Let's say we measure something that's like 68, but instead we mark it down as 86. It's just a flip of the numbers. Sometimes you read a tape measure upside down. We do the same thing. Miscounting the tape length, right? Those things are going to cause issues. If we can kind of be slow, methodical, it can help make sure that we can repeat that measurement and get the same measurement, get the same thing. And it's going to help eliminate some of that potential error with that stuff. If you repeat those, it's kind of like the measure twice, cut once thing. It's the same kind of thing, right? Repeated estimate or repeated measurements can help fix potential errors and improve your precision when we're dealing with it. This is an example of a zoomed in portion of a rod, and this is essentially what you're going to see when you look through the scope and you actually see the rod on there. Now, there are a lot of different markings on here, and this may not seem like it's very accurate, but these things can be, fairly accurate, and there's actually some things that can actually make it a little bit better. And when we talk about these, we'll go to this next slide here. This is a good slide that kind of demonstrates what these things mean. And if we take a look, when we've got this like big red 7 down here at the bottom, and you'll notice we've got a black line that's kind of right in the middle. And on that black line, there's a little bit of an arrow or one that kind of points out a little bit farther. That point right there is indicating to us that this is 7 feet. So if you had a reading and you're going to see little crosshairs on the scope, kind of like a gun, where you kind of look in, you sight it in. If the crosshairs land right here, that's telling you that measurement is 7 feet. If we go up, and we got this little black 1 that we see right here, and it's got that same little arrow. The 2 has the same little arrow. The 3 has that, so on and so forth. These things are indicating that this right here is 7.1. And we know it's 7.1 because there's a 9. You can't really see it. It's kind of cut off here. This is a 9 right here. So this rod is reading in feet and tenths of a foot. So this right here is 7.0. That's 7.1, 7.2, 7.3, 7.4. So if you're reading those things and it's right on there, that's the measurement. We can even step these things down a little bit further. As you can see kind of right here, we have the bottoms of these lines here. And these are going to indicate 1/100th of a foot. Okay. So if we go from this line right here, that's 7.2. Right underneath there, that's 7.21. To the top of that line, 7.22. The bottom of the next one, 7.23. And so on and so forth. How we do this, if you look at the middle in between these two, there is another line that is kind of opposite of the other ones. That's indicating, and it's also a little bit shorter, that's going to indicate that it's halfway in between. So this is 7.25. If we were to take the same concept right here, let's say we were to mark this point right here, what we're talking about on here is 7.15. That would be the measurement if it's sitting right here. Right underneath on those things, you can see 7.29 is right underneath the 3. So if you know that's 7.3, just go back 1, 7.29. Really 2 decimals is what we're really trying to look for on this stuff. That's kind of where we're wanting to be. Now you might notice there is a 7 in the middle right here. This 7 is not indicating because it's a lot smaller, it's tinier, it's not really linked in with anything. This is just indicating that if you're reading in this section and you can't see this 7, because when we're looking through the scope, we have a limited view, it's indicating that we're in the 7-foot range. So if you have a mark right here and you can't see any of this down here, that's going to tell you that it's 7 feet. That's why it's red. 7 point, if it's like right here, 7.35 would be that reading. 7.36 would be on the top, 7.37, so on and so forth. There are some things that we have on here, and when you have that rod, you end up having this center crosshair, the horizontal ones. That is where we take most of our readings. And then there's these things called stadia hairs, which are above and below on the vertical crosshair. So those things are going to indicate actually the distance that that rod is from the instrument, the builder's level that we're reading. And essentially for every foot that you see reading on these things, and if you were to read the top stadia hair and the bottom stadia hair, you subtract the two. If you get 1 foot, so let's say it's reading at 5 feet here and 6 feet there, if we use a little trigonometry, a little bit of calculus, we don't actually have to do that, but the way that those things are set up, it's going to tell you that it's 100 feet. So if you read 5 feet here and 6 feet there, that instrument is 200 feet away. If you read, half of a foot, okay, so you read, the 5 and then, 5.5 and, 5 at the bottom, that's going to indicate it's a half a foot, you're 50 feet away. Okay, so there's a little bit of math that we can kind of do with that. These would be the readings, kind of some examples of that stuff. If you look at this reading right here, we're at the 5 feet, so it's 5.25. The top stadia here, it's a little bit off, but on this case, we actually just go to which one it's closer, because we're just trying to be within, 2 points, past the decimal. So if it's close, go to the one that's closer. There are targets that we can put on these things that can refine that measurement to the thousandth of a foot, but for most of our readings, we don't need to be that accurate, so we're not going to put that. So just take the one that it's actually closer to. On this one, I would say it's closer to the 5.2, so that's what we're going to have. Upper stadia hair, rod reading, and then the lower stadia hair. The rod reading is going to be level with the instrument. These are not going to be level because you're looking up and you're looking down on that piece there. If you wanted to do the distance of these things, this is kind of an example, okay? You basically take the distance in feet and you could subtract the two, so you can take your rod readings. Let's say you're at 5.13 minus the 4.99. That's kind of what we have on these two stadia hairs. You get 0.14 feet. You multiply that by 100, and it's going to tell you that you're 14 feet away. So it's a way that we can kind of do that. This is going to be some examples that you can kind of go with. We're going to just give you guys some time to kind of go through and do this on your own. And then hopefully in class, we'll be able to kind of answer these questions a little bit better and test you on that stuff. So we're going to give you a couple minutes, well, maybe not a couple minutes, but about 30 seconds to kind of answer this one. We'll click on the next one and give you another example. You could pause the video, or I could sit here awkwardly. Doesn't really matter. But I'll probably click on the next one now. Example number 2. Oh, let me get out of the way. So feel free to pause the video, try to answer these questions, give you the crosshair, the rod reading, and then the top and the lower stadia hair reading. So if you want to pause, go ahead and do that right now. Same thing right here. Another example. Again, we can kind of pause that video and we can go through. This is going to be kind of stuff that's going to be on your own that I want you to try and test. You can look at the little cheat sheet if you want that we had a couple slides ago. There is one other rod that I want to kind of mention, and you don't really see these things a whole lot, but sometimes you see a rod where you have your foot marking here, and then right below it you can see an 11. What this is indicating is that every one of these is 1 inch. We don't typically use these things. You typically have a rod that reads in feet and tenths of a foot. We don't typically see rods like a regular tape measure that reads in feet and inches. They're a little bit more complicated. Normally we put them in decimal form. And so these things, you would have fractions and all that kind of stuff. We don't typically see these things. But if you do see one where you look at the foot and you have not a 9 below it, you know that it's reading in feet and inches. If it has a 9 below it, it's feet and tenths. And that's it. So hopefully in lab we'll be ready to go and move on. Thanks.